So today we want to talk about the ways to describe a function. So a function is like some kind of mathematical object, right? It's something we're concerned about. And just like, like objects in the real world, we might want to describe what this function looks like or how it behaves. So if we were describing your backpack, you'd want to be able to talk about its color or its size or its shape or some of the features it has, how many zippers it has, how many pockets, things like that. We want to develop a similar language so we can talk about a function. So we're going to talk about some of the different attributes a function has or ways that we can describe, what that function looks like or some of the properties it might have. So that's what we're going to start doing today, is building out that list of descriptors that we have so that we can talk about what a function is doing or what it's behaving like or what it's like, so that we can compare them to one another. Everybody okay with that idea? Okay. So the first descriptors that we want to talk about is the domain and range. So when we talk about the domain, we're talking about the set of x coordinates. And the range, we're talking about the set of y coordinates. So, depending on how our function is written, or our relation is written, we can describe a domain and range for relations as well as functions. Remember that the two were related, right? That if we have the set of relations, the set of functions are a subset of the relations, right? Every function is a relation, but not every relation is a function. We made the analogy to dogs and mammals, I think, is what we did. Yep, okay. So let's look at a couple of examples here, and we'll talk about how we go about determining these domains and ranges. So let's say we have a mapping diagram. And we have our domain here and our range over here. So let's say we have this mapping diagram. Does this represent a function, just as a piece of review? No. What's the issue with this? Good. The x-coordinate of 7 is used twice. It has two separate y values. So if I were to describe the domain, how many things are in the domain? 4. So that means that the set that I'm going to describe here is finite. So if I'm going to describe a finite set, I can just use a curly bracket and list the members of that set. Worth noting here, how many times was 7 used? Twice. How many times did it appear in the domain, though? Once. Remember that sets have no repeated elements or no repeated members. So even though 7 was used more than once, I only write it once when I write the domain. The same thing would go with the range. So if we look at the range, how many members do I have of the range? I have 4 members in the range as well, right? So that's a finite set. So again, I can just list the members of the range in a straightforward fashion. Let's look at another example. Or questions on this, I guess, before I go forward. Fairly straightforward, though, right? That wasn't too bad. Let's say we have a set of ordered pairs. So again, just as a review, if I'm looking at this set of ordered pairs, this is represent a function. Yes, good. And I can tell because all the x coordinates are different. There's no repeated x's, so no x is used more than once. So the domain, again, is our set of x's. So how many x's do we see used? 4. So that makes it a finite set. So I can just list the individual elements. So notice that I didn't need to write the elements in order from largest to smallest. I don't need to write them from from smallest to biggest. I don't need to write them in the order they appear. Sets have no definitive order to them, so as long as you have the correct elements in the set, it doesn't matter the order in which you've written them down inside the set. Everybody okay with that idea? Okay. The range. How many things are in our range? 1. Right? What's the only thing in the range? 0. So, my range is just going to be the set with a single member, that member being 0. Did it matter that 0 is used 4 times? No. When we write our sets, we only write the element once. Doesn't matter how many times it was used in the relation, it'll only appear in the set 1 time. Everybody feel okay so far? Okay. Now, we talked about in our last class periods finite sets and also infinite sets. When we describe domains and ranges, and really the rest of these descriptors, we're going to use a different notation to describe these infinite sets. This notation I would expect you guys to be able to generate on your own because it's much simpler from a notation standpoint than the things that we had discussed on the first day. That other notation is called interval notation. So let's just kind of summarize what we just said there. So this is an alternate notation for infinite sets. And I should probably say that, to be clear, this can't be used for all infinite sets. But for the infinite sets we'll see in this class, you can use it for all of them. So the form for the notation is going to be a lower bound with a comma and then an upper bound. I'll talk in a moment to clarify what I mean by lower bound and upper bound. And then here, will be a bracket or a parenthesis to start it. And then we'll have a bracket or parenthesis to end it. And I'll talk about how you make the decision about which one you'd use in a moment. But this is what an interval notation looks like. So it's going to be start with a bracket or a parenthesis. It's going to have a lower bound, like a number, and then a comma. You'll have the upper bound, again, just another number, and then a bracket or parenthesis to end. And that's all an interval looks like. So let's look at some examples of writing these interval notations. So let's say the set that I want to write is -1 less than x less than or equal to 3. So for this set of numbers, The lower bound is the smallest number that we're concerned with. It's one of the boundaries to this set. It's the lower boundary. What number is the smallest number we'd be concerned about when we're talking about the things between -1 and +3? It's not a trick question. -1. So that's my lower bound. What is my upper bound going to be? 3. Everybody happy with that? Not too difficult to determine that. We'll do some more examples though. Next thing we need to do is decide whether these, I should be using a parenthesis or bracket. So the bracket indicates that that value is included in the set, and a parenthesis means that it's not included. So if I look at the -1, if I put -1 in for x, is that true? Specifically, we'd be caring about this part, right? Is -1 less than -1? No, right? Everybody agree with that? So that indicates to me that -1 is not a member of this set. It's not included. I should have a parenthesis for the -1. Now let's consider the 3. If I put 3 in for x, the part that I'm really concerned with is the yellow part that I circled. Is 3 less than or equal to 3? That part is true. So here, I'll use a bracket. So this is what an interval looks like. So when I see this, I see that we're talking about the numbers between -1 and +3, not including -1, but including +3. Let's do another example. What if we have x is less than 5? What's the lower bound on this? The smallest number we'd be concerned with. Well, x is in a number. So we're the smallest number. What was that, Marshall? Okay. In which direction is the infinite?
Smaller, so it could be 4.99999, or it could be 4.88888.
Good. So if we're talking about on the number line, like 5 is here, this end, which is anything it could be, we're going to represent with the symbol for infinity. So that the symbol for infinity is a sideways 8. And because we're talking about the left end of our number line, we're talking about the negative number, so that's going to be a negative infinity. The upper bound for this set is then 5. Okay. Is negative infinity an actual number? Is that something that x can equal? No, right? All infinities are not actual numbers, whether you're talking about a negative infinity or a positive infinity. They're always going to have a parenthesis. Since they're not actual numbers, they're never actually included in our set. Now let's look at the 5. For the 5, is 5 included in x is less than 5? So if we replace the x with a 5, is 5 less than 5? No. So that means that 5 is not included, and when it's not included, I use a parenthesis. Okay on this? Let's do one more, and we're probably should feel okay about these intervals. So maybe x is greater than -3. So the first thing I want to do is find my lower bound. In this case, the smallest number, when we're talking about x is greater than or equal to -3, is, so the smallest, -3, but the biggest is infinity. And I like to write positive infinity when I write it to differentiate them. Helps reinforce that I've put the lower and upper bounds in the correct positions.
Excuse this interruption in the high school. Would the following students please come to the office quickly right now for pictures or to let us know about pictures? Spencer Whitford, Angelina Suave, Kyle Hadar, Olivia McEtrick, Gabriel Myers, Julia Gallo, Luke Hogan, Anthony Gaith, and Jonathan Hubbard. Come on down to the office.
All right. Let's look at the -3. Is -3 included or not included? Included. Good. Because it is a or equal to inequality. So because it is included, we should use a bracket. The positive infinity, since it's an infinity, we should always use a parenthesis. Feel okay on the interval notation? So returning to domains and ranges, let's look at an example where we have to use these intervals. So we've returned to talking about domains and ranges. And let's say we have this graph. We'll start with the domain. I guess first thing, before we even start with that, we should recognize that the domain and range in this case will be infinite sets. How do I know that? Just by looking at it? How many points are on this curve? Infinitely many. Remember from geometry that a line is made up of infinitely many points. It has two endpoints, sure, but there's infinitely many points in between. Everybody okay with that idea? You remember that? And if the domain and range are the set of x coordinates used and the set of y coordinates used, I have infinitely many of those potentially also, right? So I know right away that I'm going to be needing to use interval notation to describe those domain and ranges in the case that I have infinitely many. Okay. Let's look at the domain. Remember, the domain is about the x's. What's the lower bound for my x's? -5. So if we start on the far left, the first x coordinate used is -5. And the upper bound for my domain is 7. If I go all the way to the right, the last point used has the x coordinate of 7. Now let's decide whether these need brackets or parentheses, whether they are included or not included in the graph that we've shown. So let's start with the -5. Is there a point on the graph that actually uses the x coordinate -5? Yes, right? This point right here actually has the x coordinate of -5. So because it's actually part of the graph, it should be included, and I will use a bracket. How about the 7? It is also included. We should also use a bracket there. Now your natural question would be, what would it look like if I wasn't supposed to use a bracket? So instead of having a dot that was filled in, we'd have an open point like this. And what we're doing there is we're borrowing the notation that if we wanted to graph like x is greater than 5 on the number line, remember we used an open circle on the number line to indicate that 5 wasn't included. You guys vaguely remember doing this from like your algebra or pre-algebra courses? We're borrowing that same opened and closed notation here for the points. Okay, so this, if it were that case, in the green, we'd have a parenthesis instead of the bracket. Okay? So just the parenthesis. So if it was the green, I would have the green mark. But that's all aside. So before I make this too confusing, let me erase all that stuff. All right, now let's go to the range. What is the smallest y value, or the lower bound on the y values? I heard somebody say -3 right away before I could even finish my question. Very good. And the largest or upper bound is the 5. Okay. On the -3, bracket or parenthesis? Bracket is correct. And also on the 5. Yep, bracket on both. Yeah. I'm sorry, what? Yes, the point on the graph, yes. And the other thing worth noting is that these should match. So if the first point was not included, it would have a parenthesis to start the domain and the range. So those typically would match. Let's do another example. Okay, so let's do this one. What is the lower bound for the domain here? What was that? It's not -4. Remember, the domain is concerned with the x-coordinate. What is the smallest x, though? It's not 6. It is -infinity. So notice that this arrow is pointing up and to the left. What part of the x-coordinates go to the left with the arrow? That's the -infinity. Everybody okay with that idea? Again, I know that's tempting to go to the information that's given first. I would encourage you rather to read the graph for the domains from left to right. So look for the leftmost point for the lower bound, and the rightmost point for the upper bound, for the domains anyways. The upper bound here is, for the domain, 6. Very good. For the -infinity, parenthesis or bracket? Parenthesis. Always parentheses on the infinities. For the 6, parenthesis or bracket? I hear some disagreement here. It is a parenthesis. Why? Yeah, because it's the open circle. Yep, have to be careful. Let's do the range now. So the range is about the y-coordinates. What is the lower bound for our range? -4. It's the lowest point on the graph. The upper bound is? Good. I like to write positive infinity, but you don't really need the plus sign for the positives. Okay. And I know that because the arrow is pointing up. And positive infinity lives on the up part. For the -4, bracket or parenthesis? Parenthesis. For the positive infinity? Parenthesis. So again, the part that is concerning the 6 and the 4, notice that the bracket and parentheses match up, right?
Sorry.
No, that's okay. Please ask your question.
No, I just went there. So I was looking at my notes.
You got it?
I think so.
Okay. How do you guys feel about these domains and ranges using the intervals? Not too bad? Okay. Good. The next thing I want to talk about is where the graph or the function is positive, negative, and 0. So when we talk about positive, negative, and 0, we're talking about where the y-coordinate is positive, where the y-coordinate is negative, and where the y-coordinate is 0. When we ask these where questions, the way we answer that is with the x-coordinate. Everybody okay with that? So if I'm describing where this graph is negative, I might say from, when x is -3 all the way up until x is +8 or something like that. Everybody okay with that idea? And I would describe those parts using an interval more often than not. So if I'm looking at a graph, where would the graph be positive? What would that look like on a picture? So it's above the x-axis. So the graph is positive whenever it's above the x-axis. Negative, it's going to be below the x-axis. And 0, it's going to be on the x-axis. Okay. I think we understand positive, negative, 0, at least what we mean conceptually. All right. So let's look at a picture here. Okay. So, how many positive parts of the graph do you see? 2. I agree. We say there's 2 positive parts of this graph because there's 2 parts where the graph is above the x-axis. Everybody agree with that? How many negative parts of the graph do we see? I see 1. There's 1 piece of my graph that's below the x-axis. Everybody okay with that idea? And then how many 0 parts of the graph do you see? 2. There's a part right here and a part right here. Okay. So let's now write down these intervals of positive, negative, and 0. So we'll start with the positive part. for this first section of the graph, what is the lower bound for that first section of the graph? The first blue part that I've circled there. Well, again, so we've heard lots of answers yelled out. One of them was correct. So again, we're talking about x coordinates when we're describing where the graph is positive, negative, 0. And we want to start on the farthest left-hand point if we're talking about x's. So that would mean we'd be looking at this arrow pointing all the way to the left. The lower bound would be negative infinity. Yes, so we're looking at the left and right parts, not the up and down parts, because we're talking about x's and not y's. But good question. The upper bound then would be negative 2 is correct. Everybody agree with that? So basically we go from here to here. That part of the graph is above the x-axis, right? On the negative infinity, we have a parenthesis. On the negative 2, we have a... Okay, so some people have answered both. This is a parenthesis. Why is it a parenthesis rather than a bracket? Where is the point negative 2, 0? It's on the x-axis. It's not above the x-axis, right? So negative 2 should not be included with the stuff above the x-axis. Everybody okay with that? Okay. Then I'm going to do that union symbol. You remember we talked about this earlier? And I'm going to do the next part of our graph. So I want this section of the x-axis. What is the lower bound for that other positive part of the graph? 5. And the upper bound is positive infinity. Very good. Now for the 5, should I have a bracket or parenthesis? Parenthesis, and the positive infinity, parenthesis. Any questions about what we've done here? Okay. Next, we're going to talk about the negative part of the graph, which goes from there to there. What's the lower bound for the negative, Clayton? Of course. Yes, Marshall. Negative 2. And the upper bound on the negative is positive 5. I knew what you meant. Everybody happy with that? Okay. On the negative 2, parenthesis or bracket? Okay. Is negative 2, 0 below the x-axis? Is that point? It's on the x-axis. So it should not be included with the stuff that we've listed as negative, which means below the x-axis. Is everybody okay with that idea? So again, if you're not sure, so this is our positive part. Let me color code it the same way as there. This part is the negative part. And this part, oh, that did not pick a different color here, is the 0 part. So if your point is in with the yellow brick, you'd use a bracket if we're talking about negative. Our points, the negative 2, 0, and 5, 0 that we're concerned about, are both on that kind of red section of the graph where the 0 is, right? Okay. Does that help to visualize it that way? So the 5, parenthesis or bracket, parenthesis. And that's it for the negatives, right? There's only that one negative section. Now let's do the 0 part. How would I write that? Okay. So remember, when we're writing these, we're answering the question, where is the graph 0? And we answer that using x coordinates. Almost. So, closer. Here's the thing. How many points are 0? 2. That's what kind of set? Finite, right? And how do we write a finite set? We use the curly brackets and we just list them. That was sneaky, right? So all of a sudden we stopped having to use interval notation because we only had 2 points that were 0. We didn't have an infinite number of them like we had for the positives and negatives. So I changed the notation I was using to write my sets. Let's do another example of this, yes? And we can do many more if we need to. We have certainly have the time. But if you understand this one, you should be pretty good. I think that's labeling everything that we care about there. So first things first, let's identify how many positive, negative, and 0. Oh, I do have one more point that I need to label. Sorry about that. Definitely need a label for that. You gotta know where that's at. Okay. How many positive parts do we see here? 2, right? We see this section here and that section over there. Everybody cool with that? Okay. How many negative parts do you see? 2. See this section here and this section here. And then how many 0 parts do we see? 2 as well. All right. So if I look at that first positive section, that's running from there to there, right? Everybody agree with that? Okay. That is infinite because it's a line segment. Okay. What's the lower bound here? Where x coordinate does that begin with? -4. And what x coordinate does that end with? -2. We're just talking about this little section right here, right? The -4 should have a parenthesis or a bracket. parenthesis, because negative 4, 0 is on the x-axis, not above. Hannah, you had a question?
I was gonna ask, how did you get -2?
Okay. So you see the green section is the part of the x-axis we're interested in, right? So this is negative 4, and that is the negative 2. Does that make sense? Because after that, the graph is below the x-axis, right? So it wasn't random, it was intentional, right? But no, those are good questions. Keep asking things, okay? If something's not clear, ask about it so we can clear it up. The lecture usually goes much better if you're understanding things along the way. So if you're missing something, please speak up and let me know. I don't read minds. So, okay? The negative 2, parenthesis or bracket. Parenthesis, why?
On the
Well, no, that point is here, right? But parenthesis is the correct answer, but why? Because it's an open circle, which means that that point is not included. So there I use the parenthesis because it was an open circle, indicating that point is not included. Okay. I'll do my union, and then I'll move over and do this section of positive now. What's the lower bound on that section on the right? 4. And the upper bound is? Very good. And you say they're, what did you say? They're both parentheses is correct. The 4 is a parenthesis because 4, 0 is on the x-axis and not above. And the infinities get a parenthesis always. Okay. Let's do the negatives now. So we'll start with this section here first. So what do we start with here? -6, and it goes to -4. On the -6, parenthesis or bracket? Bracket is correct. Notice here that the point -6, -4 is below the x-axis, so it should be included with the negatives. The -4, the other end, parenthesis or bracket? Parenthesis. That point is here. That's on the x-axis. So it should not be included with the negatives. Do our union. And then we have, it's just like a connector. It basically just means or. So the parts that are positive are -4 to -2, or from 4 to positive infinity. Does that make sense? Okay. So we'll look at the second negative section. Where does that begin at? -2. And where does it end at? 4. The -2 should have a parenthesis or bracket? Bracket. The 4, parenthesis. Very good. And then lastly, we'll do the 0 part. How many zeros do we see? 2, which is finite. So we use the curly brackets for the finite ones, and we just list them. Okay. When does this class end here? 10 minutes, okay. Let's do one more example here, yes? Huh? Why not? Okay. All right. Take 5 minutes. Try to do this on your own. And we'll take the last 5 minutes and I'll talk through how we would do this. But try this on your own for a few minutes. You guys have been doing a pretty good job answering questions as I've been asking them. So take a few minutes here and see what you can do on your own. And then we'll go through the answers here as a group in just a moment. Okay?
So if there's a 0, are there 3 0 parts?
There's more than 3.
Count the one.
More than 4. There are infinite zeros. So it's a little bit tricky how to represent this situation for the zeros. The other parts should be fairly similar to what we've seen before. The zeros, we have to be a little bit careful on how we're doing that. So for the positives, I see 2 positive sections. The first one goes from -7 to -5. And the second one goes from 3 to 6. Note that 6, 4 is still on the positive side. So I included 6 with a bracket. I see 1 negative section that goes from 0 to 3. So here's my positive sections. Here's my negative section. And now the zeros are a little bit tricky. So there's 2 0 sections. There's this section that has infinitely many zeros. That section I should write using an interval. So that interval goes from -5 to 0, and -5, 0, and 0, 0 are both on the x-axis, so both of those should be included. And then I have this one extra guy over here. That's a finite 0. So I'll do a union, and then a curly brackets around the 3.
Why would it have the brackets around -5 and 0?
Because the point -5, 0 is on the x-axis, so that should be included with the zeros. And the point 0, 0 is on the x-axis, that should be included with the zeros. The square brackets, yes, are for included. Parentheses are for not included. Mm-hmm. Follow-up questions on this one? This was quite tricky, particularly this part with the zeros at the end. Okay, so when we're talking about positives and negatives, it is. 0 is defined as the stuff that's on the x-axis. So in that case, the -5, 0, and the 0, 0 should be included when we talk about the stuff that's on the x-axis, because it is. Does that feel okay? We're going to stop here.